Fine. So in our previous class, we are done with object-oriented programming, and today we'll be starting our second module called as .NET Framework Basics or .NET Framework. Fine. So let's get started. Firstly, let's try to understand what is .NET Framework. I hope the complete screen is visible to you, right? There is no window barring something. Good. Good. Let me read out the slide first, and after that I can explain you what it means. So the .NET Framework is a technology that supports building and running the next generation of applications and XML web services. Sorry, I'm muting you. Okay. So what is .NET Framework? .NET Framework is a technology that supports building and running the next generation of applications and web services, and obviously using your .NET based technology. So what is a framework? A framework is something like a ground or a foundation which helps you in creating the applications and web services or web applications or any type of applications using your .NET. And for that matter, every language will have their own framework. Okay, and for example, if you are aware of Java, then you might have come across something called as Java Virtual Machine or Java Runtime, they call it, right? So similar to that, it's a package of all the components required for creating and maintaining your applications created in .NET. Fine. Good. And what are the, and let's quickly go through the functions of it, and we don't have to worry much about these functions, but for your understanding, we'll try to understand what are the different functions of your .NET framework. Vishwa Krishna is there with you, right? Good. So what are the different functions of your .NET framework? To provide a consistent object-oriented programming environment independent of the location at which object is stored and executed. Okay, this statement says that the primary function of your .NET framework is to provide a environment or a object-oriented programming environment which will maintain consistency across the place at which the object is created and the place at which it is getting executed. For example, think that you have created a class or a object using your code locally using Visual Studio, and obviously Visual Studio uses .NET framework for creating that object, and when you are executing it in real time, for example, if you are executing it on a Internet Explorer browser and it is about a web-based application, there it should be supported in a similar environment, right? So for that reason, what happens, even on your even on your Internet Explorer, you will be installing a MIME, they call it MIME, MIME version of your .NET framework, and this MIME version of your .NET framework, which is installed on your Internet Explorer, will create similar environment for the object to get executed there. So in spite of the place where your object has been created and the place where the object is getting executed, the consistency of environment should be there. So for that reason, your .NET framework supports that kind of consistent object-oriented programming environment. Making sense? Good. And the other feature of it is to provide code execution environment that minimizes software deployment and version conflicts. Okay, so what happens? This is again related to the deployment and version conflicts of your framework. Okay, when you are trying to get the code executed, for example, think that you have created it on a machine which uses your AMD processor. Fine. And you are trying to execute it on a machine which uses Intel processor. There again, your .NET framework, what will it do? It contains some components of your Microsoft which will automatically translate or which will perform similar functions to your similar functions in both your processors. In that way, what will it do? In spite of the environment at which it is getting deployed, and sometimes there might be different versions of the environment, like you have a operating systems like your Windows 7, and sometimes there might be some other operating systems called as Windows 8. And when you are executing your program, you don't want your program to get executed differently in two different environments, right? So it will take care of the deployment and version conflicts. So in spite of whatever deployment, whatever environment it got deployed, or in spite of what version of the particular software it is using, you'll try to create a similar code execution environment. Making sense? Good. And the third point says that to provide a code execution environment that promotes safe execution of the code, including code created by an unknown or semi-trusted third party. In reality, let me give an example which makes you understand what does this mean. In reality, you might be coming across many third party frameworks or applications which you might be referring to, or which you might be adding to your code to utilize the customized features or benefits of that third party controls. For example, think that you want to display some rich text on your application, like you want to display HTML, you want to display Word documents, PDFs, everything in one control. You can't create a control like that, right? Even if you can create it quickly, it will take a lot of efforts. It might require lot many developers to work on that particular project, and most of the time it will take very long time for you to create it. So what happens, some third party vendors will be there, they'll create this kind of third party frameworks or applications, and they'll sell it to you, and you can use the customized features of that applications. So when they are creating a third party control or a third party framework or a third party API which needs to be used in your code, again it should be safe, right? And it should not perform unintended functionalities with your application, right? Yes or no? Nobody wants that to happen. So for that reason, your .NET framework, what happens, it will convert your code which you have written using your .NET based development environments into some other form of the code which we'll look at later, and that is called as managed code. And even if there is an unmanaged code which is created by somebody else, that would also be executed by your .NET framework safely. Making sense? Good. So to provide developer experience consistent across widely varying types of applications such as Windows based. So think that you are a desktop based application developer, and think that one of your friend is a web based developer, and tomorrow you got an opportunity in your company, and you are asking your friend to join your company. He should not feel it odd to work with your kind of Windows based development, right? So for that reason, what happens, your .NET framework will try to create consistent framework or development environment which will make no difference or minimum difference across the type of applications which you are creating. Fine. Whether it is web based or Windows or web services, most of the classes remain same, until and unless there are some specific classes or specific functionalities which are very specific to the place where it is getting executed. Otherwise it will not get changed. Making sense? Good. So did we understand what is .NET framework and what is the purpose of your .NET framework and what are the major functions of it? So majorly you should understand that it provides a environment for creation and execution of your code. Fine. Good. And for example, you should understand that, for example, if you are trying to install or deploy your ASP.NET or .NET based web development code on a server, there for the code to get executed on that particular server, you will have to have .NET Framework installed on it. Okay, so .NET Framework is mandatory for your code to get executed. Fine, understood? How will you add .NET Framework to your code? Good. So here, if yours is a latest Windows, then you will click on turn Windows features on or off, and in that it will specify your .NET Framework, and you'll check it and click OK. Okay, my machine takes a long time, don't worry. Okay, so otherwise it is available on your Microsoft website. You can use any one of them. Making sense? Good. And it's free. And what are the components of your .NET Framework? There are majorly two different components associated with your .NET Framework. One is called as Common Language Runtime or CLR, and other one is called as Class Library. We'll understand both of them in detail in our next slides. So before understanding what are the components of your .NET Framework and what are the individual functions of each and every component, let's try to understand something called as a compilation. Can someone tell me what is compilation? We discussed it in one of our previous classes. What is compilation? You can unmute yourself and start talking. What is compilation? Anyone? If you know, say yes. If you don't know, say no. Good. Vishwa, what is compilation? I was expecting an answer from you. Please go ahead. Vishwa or Prakriti, please unmute yourself and start talking. Prakriti, we can't hear you. I think you got yourself unmuted, but we are unable to hear you. Fine, no problem. Let me explain what is compilation. So, compilation, basically, you should understand that compilation is a process of converting the code written in one language to other language. And even if you are converting your Java code to .NET or .NET code to Java, that is also called as compilation. Then, however, there is one common form of compilation which everyone will be using, or which we would be coming across commonly as a developer, and that form of compilation is converting the code which is written in your high-level languages like your .NET or Java or VB or your ASP or whatever, okay, into the language which is understood by your microprocessor. Your microprocessor cannot understand anything apart from the binary code or machine code or native code. Fine. Don't get confused with three names. Three of them, they are same. Okay. And your microprocessor understands only native code or binary code or machine language code. Then the process of converting your high level language code into your binary or native or machine language code is the most common form of compilation. Making sense? Understood or not? Good. So how does compilation happen in your .NET? Basically, in .NET, compilation doesn't happen in one phase, but it usually happens in two different phases. So in the first phase, your language specific code, and you should understand that .NET framework is not specific to C#, but it has almost 8 to 12 languages under its umbrella. Okay, and there are many other languages. Most common languages would be C# and VB.NET, and Microsoft's statistics say that C# is used by more than 90% of the projects, and VB is used by more than 40% of the projects, and remaining languages constitute less than 5%. Fine. So, however, however, the process of compilation stands same across all the languages. So as part of our first phase of compilation, the language specific code, whether it is your C# or whether it is your VB or whether it is your C++ or whether it is your any other language supported by your .NET, that language specific code will be converted into your intermediate language called as Microsoft Intermediate Language Code. Fine. And under the second phase of compilation, your MSIL will be, or Microsoft Intermediate Language, we call it commonly as MSIL. So MSIL would be converted into machine language code. Fine, making sense? And you should understand that this second phase of compilation is called as just-in-time compilation because it happens just before your code gets executed. Fine, understood? Why two phases? We'll come to that point. Good. So what is MSIL? As part of the first phase of the compilation, the language specific code is converted into MSIL, which is the CPU independent set of instructions that can be efficiently converted into your native code. MSIL includes instructions for loading, sorting, initializing and calling methods on objects, as well as instructions for arithmetic and logic operations, control flow, direct memory access, exception handling and other operations. So what does this mean? At the end, your MSIL is nothing but everything which is written in your code which gets converted into a intermediate language. Fine. So why do we need a intermediate language for this purpose? Basically there are 2 or 3 different reasons for this. The first major reason quoted by your Microsoft is that they don't want to compile everything. So when you compile your code, what happens if if everything happens at your runtime? Okay, then what will happen? Your compiled code consumes some memory, right? Yes or no? It consumes some memory. So you don't want to use your memory space unnecessarily when it is not being used. Think that there are 100 classes in your code. You'll not be using 100 classes or 100 references every time, right? You'll be using only 5 or 6 of them at a given point of time. So this MSIL, what it will do, it will intermediately compile the code and save it. And under the second phase of compilation, which happens just before your code gets executed, what will happen? Only the necessary code components would be compiled into your machine language, which requires very less space. Fine. So the first purpose is efficient use of your system's memory. Making sense? There is a second point associated with it. The second point is that, think that there are 4 developers in my team. Okay, one is Prakriti, other one Sai Krishna, third one is Vishwa, and fourth one is Krishna. So all of them, they use 4 different languages. Prakriti doesn't know anything apart from Visual C++. Sai Krishna doesn't know anything apart from Visual C#. Vishwa knows only VB.NET, and Krishna knows only F#. Fine. However, I wanted to create a application which is in which there are 4 different components and each one should be taking care of one of them. Making sense? Then at the end, when you integrate the code, everything should be understood by your framework, right? So if you are using 4 compilers and 4 of them, they are compiling the code at your runtime, it will be a very big mess and it will take a large time, large memory resources, large amount of memory resources and processor time, right? So instead, MSIL is independent of all the languages. So what will happen? Every language code would be individually converted into MSIL and integrated and saved at some place. And for the second phase, the source or input is only one type of code, which is MSIL, right? So you need not convert everything into your native code at the runtime. Making sense? So that's the reason why here MSIL is used. Did you understand the purpose of MSIL? Awesome. Good. So who takes care of this first phase of compilation for that matter? Every language will have their own compiler. C# will have C# compiler, VB will have VB compiler, and Visual C++ will have, yes. So for that matter, Vishwa, what happens, the sole essence or the major intended requirement for the initial versions of your .NET framework was that the code should be made interoperable and language independent. Okay, that's the reason why, if you, when we were discussing the basics of your .NET framework or basic concepts of your .NET, you'll understand that everything is related to your interoperability, or everywhere at least proper measures would be taken to make your code interoperable. Making sense? Good. And who takes care of the first phase of compilation? Language specific compilers will be there. Okay, what are language specific compilers? You have C# compiler for C#, VB compiler for VB. So every language will have their own compiler, and apart from that there are third party compilers also. Okay, some third party organizations, they came up with their own compilers with added features. Fine. So you can use any one of them, but Microsoft suggests using language specific compilers provided by the .NET framework. Making sense? Good. Second point. So what is the second phase of compilation? Before code can be run, MSIL must be converted into CPU specific code and usually called as native code. This is also called as just-in-time compilation, and compiler performing this is called as JIT compiler. And JIT compilation takes into account the possibility that some code might never be called during execution. Instead of using time and memory to convert all the MSIL in the PE file to native code, it converts MSIL as needed during the execution and stores the resulting native code in memory so that it's accessible for subsequent calls in the context of the process. So let me quickly explain what does this mean. So as a second phase of your compilation, particular component associated with your MSIL, as we discussed earlier, only the particular component which is required at a given point of time would be converted into native code instead of converting everything, right? Because at a given point in time you will not use 100% of the code, right? There will be only references to few sections of your code at a given point of time, which means that you need not compile everything at one point. So what will happen? Just-in-time compiler will convert it on need basis. Making sense? Good. So the second phase of compilation is called as just-in-time compilation, and the compiler which takes care of it is called as just-in-time compiler. Fine. And you will not find a mention of it at many places, but you should understand that there might be many just-in-time compilers supported by your .NET framework. Based on the design of your CPU and based on the design of your operating systems, you would be your .NET framework would be using a very specific compiler to your environment for suiting the necessity or need at that given point. Fine. Making sense? Good. So let me quickly move further. Our next point, what is a assembly? If somebody asks you what is a assembly, I don't want you to remember this definition, but the only thing which you should say is that assembly is the basic unit of deployment. What is deployment? Deployment is a process of sharing your code with the intended users. Fine? Yeah, but yeah, that's fine. So what is deployment? Deployment is the process of sharing the code with your end user or intended user. For example, think that I have created Skype application, and four of you, you wanted to use the Skype application. What will I do? I'll compile my code and I'll create an assembly out of it called as exe, and I'll share the exe with you. You will install it on your local machine so that all the code gets deployed in the compiled format in your local machine, and it can be used by your microprocessor, right? Have you ever installed a application? It requires a exe, right? So exe is a form of executable. However, if you want to deploy it on a application server, then there would be some other type of assembly called as DLL, which contains the compiled code again, and that would be saved on your application server, so that on request basis or need basis, that would be given access and that would execute the code using the .NET framework installed on that machine. Making sense? So what is assembly? Assembly is a basic unit of deployment. So what is assembly? An assembly is a collection of types and resources that are built to work together and form a logical unit of functionality. And assembly is the basic unit of deployment. Making sense? Good. So what does your assembly contain? Your assembly contains compiled code. So that being said, we have two different types of compiled code. One is your MSIL and other one is your native code. So which compiled code would be saved in your assembly? Quickly make a guess. Native? No, actually it will contain MSIL code. Think logically. We have discussed earlier that native code would be generated just before your code gets executed, right? So it doesn't have to be saved somewhere. So your assembly contains MSIL. Making sense? Apart from your MSIL, your assembly also contains something called as metadata. So what is metadata? Metadata describes the types, members and references in your code, and metadata is stored with the code. Every loadable common language runtime portable, or assembly we call it, contains metadata along with your MSIL. The runtime uses metadata to locate and load classes, layout instances in the memory, resolve method invocations, generate native code, enforce security, and set runtime context boundaries. Okay, so let me quickly explain what does this means. For example, think that you are traveling from Connecticut to New Jersey. Fine, and you ended up at your destination, and you have arrived at the city called as Parsippany. Okay, so in Parsippany you don't know your friend's address. Okay, so what will you do? You know his address, but you don't know how to reach there. You will use your Google Maps to quickly navigate to that place, right? So similarly, your code can contain hundreds of types, and each type can have n number of members defined inside them, and one type might be referencing other type. Yes or no? Understanding or not? So to quickly reach through the particular class or a type or a reference which you might want to access and execute at a given point in time, you should have some schema or map which explains all the types, members and references in your code, right? So that is called as your metadata. So during your compilation, metadata also would be created along with your MSIL, and that would be saved along with your MSIL in your PE file or portable executable file or your assembly. Making sense? Good. So the next term which you should understand is namespace. What is a namespace? You might have come across something called as system.web or system.web.ui or system.threading or system.string.modifications or something like that, right? Good. So system is a namespace. Yes. So anything which is a logically grouping of types is called as a namespace. What is a namespace? Namespace is a way of logically grouping of types. So what is a type? As we discussed earlier, type is something which is used for which is a template used for creation of individual objects, something like your class or interface, right? So if you want to group some set of classes and interfaces together based on the functionality they perform, then that is called as namespace. Fine. System says it contains all the classes, group of classes which are related to your system. Fine. And system.web says that it contains all the details or all the types associated with your web-based development. System.windows will tell that it contains all the types associated with your Windows-based development. Making sense? Good. So all the types which are required for creating certain functionality, or all the types related to certain predefined functionality, would be grouped together using your namespace. Understood, or you want me to explain it again? Good. Good. So what is the purpose of namespace and what are the properties associated with it? So these are the few important properties associated with your namespace. They organize large code projects. Okay, think that, forget about the namespaces which were provided by your .NET. Okay, think that you have 100 files which you have created, and all these 100 files together contain some 300 classes, and you are working on a banking project which contains details related to your credit cards, bank accounts, and your trading account. Fine. Then instead of vaguely arranging them in your code can be meaningfully organized into set of classes associated with your credit card. You can group them together, and set of classes associated classes and types, as we call it, including interfaces, delegates, and enums, everything. So they can be put together in one group, right? So in that way, you can arrange your code properly when you are dealing with large projects. Yes or no? And even these larger groups, they can be again meaningfully divided into sub functionalities by using a delimiter called as dot, right? Like your system.web, system.ui, system.web.forms, system.web.services. Got it? Good. So the using directive obviates the requirement to specify the name of the namespace for every classes. So you might have understood, or you might have observed that every class which we have created till this point today, we were having something called as using system dot windows, using system dot UI. So multiple using statements were defined at the top of your class, right? So this says that any class which is defined in that namespace can be referred in this particular class. Understood? And the fourth property associated with your namespace is that namespace can be used for uniquely identifying the given type. So think that you might be, as we have seen earlier, there is a data grid class which is defined in your system.web.ui and system.windows.ui, right? So you want to have two different classes with the same name, then you can differentiate them by the namespace. Shall I proceed further? Is it making sense? One other word associated with your assembly which you should remember is your manifest. So what is manifest? An assembly's manifest contains all the data needed to specify the assembly's version requirements and security identity and all metadata. Manifest maintains the information about the assemblies like version name, locale, and any optional strong name that uniquely identifies the assembly. So let me quickly explain what does the manifest means. For example, think that you have created a assembly which is a file again like your exe or dll, and you have one other assembly created with the same name. Then there should be something which differentiate between both the assemblies in terms of the demographic details, like when it has been created and what is the name of it, what is the version name of it. If there are two different files with the same name, then what is the version name associated with your each file? And if there are two different files with the same names and same version names, then how are we uniquely identifying them? You can be creating something called as a strong name associated with each one of them, which would be a combination of the time at which it is created, name of it, and physical location of it, and the version number. Using all of them, you can create a strong name and tag it specifically to that assembly so that it can be uniquely identifiable. So your manifest contains the details, demographic details associated with your assembly or PE file, which will make it uniquely identifiable. Understood? And you should also understand that manifest also contains your metadata. Fine. So metadata is a subset of your manifest. So what does your assembly contain in total? Assembly contains manifest and your MSIL, and manifest again internally contains the demographic details along with your metadata. Making sense? Good. Fine. Our next term is called as garbage collection. So before understanding what is garbage collection, let me quickly explain you something called as stack and heap. Do you know what is a stack and what is a heap? No? Say yes or no. Anything is fine. Anyways, I'll explain that to you. So both stack and heap have let me avoid this confusion. Stack and heap, both stack and heap, they are memory allocations in your system's memory. What is your system's memory? RAM, right? What is your system's memory? When we talk about memory associated with your system, that should be your RAM, random access memory. So when we talk about memory, you will understand that you will call that your system has your 5 GB RAM or 6 GB RAM or 8 GB RAM, right? So this RAM would be used across by all the applications running on your machine at a given point in time, right? So when your application is running on your machine and using your RAM usually contains two different types of memory allocations inside it. So if you are arranging, so think that you have to arrange all the goods in a given room. What you will do, you will again internally create arrange few of them in boxes, arrange few of them in bags, arrange few of them in covers, something like that, right? So inside your memory, again, the data can be arranged in multiple memory allocations. So among them, the most popular ones would be your stack and heap. Making sense? That being said, when we are talking about your stack, let's take an example and try to understand it. So think that you have 100 books. We'll get into that point, Vishwa. Give me some time. Think that you have 100 books and somebody came up to you and asked you to arrange all your 100 books in certain format. So you started piling up one book above other, and you have created a stack of 100 books one above other, right? So this way of arranging is called as stack based arrangement. Understood? And stack has a unique feature associated with it called as last in first out. What does this mean? This means that the object or element which is placed lastly in your stack should be removed first. Let's try to understand it with the example of stack of books which are piled up one above other. So think that there are 100 books and somebody asked you to remove the 40th book from it. Okay, and can you directly remove the 40th book? No, right? Can you start removing it from the bottom? The stack will collapse, right? So you can't do it that way also. The best way to do it is start removing everything which is placed above your 40th book, and after that you can access the 40th book, which means the lastly inserted element should be removed first. Making sense? Good. So that is the property associated with your stack. And secondly, let's try to understand what is your heap. Think that you own a laundry. Fine. And so you have collected 100 sets of clothes from your customers today, and you started getting them washed using your machines, and you have got that dried using your machines. And after they are washed and dried, how will you get the clothes from? Will the machine directly press them and fold them and arrange them in a particular order and give it to you? No, right? So how will it give you? It will give you in a random allocation. So it will give them as a heap. So you will pull everything out and you will place them on floor, right? So this way of random allocation of a element or random allocation of a group of objects is called as heap. Making sense? Good. So in your heap again, you are grouping a set of elements in a random order. Okay. For example, there are 100 clothes which are piled up, and as a custom, when somebody comes to you and asks for his clothes, what you will do, you will immediately pull out the cloths from your heap and you will press them and give them. Fine. Or forget about pressing, you will just give them. You don't provide pressing service or ironing service, so you will just pull them out of heap and you will give them. Making sense? So somebody came to you and asked you to give his black shirt. Fine. And you started searching in the heap, there are 5 different black shirts. So how will you uniquely identify his shirt? For that, in laundries usually, I don't know how it happens here in US, but in back in India, I used to see that every cloth used to have a tag attached to it, and on the tag they used to write the person's phone number and name, or some bill number or something like that, right? Have you ever observed that? Good. Similarly, in your heap memory also, if you are placing the objects in your heap, every element or object which is placed in your heap will have a tag attached to it, which holds the reference to the particular object, and which holds the address of the particular object, and this particular tag is called as pointer. Fine. And what does pointer hold? Pointer holds the address of the particular object which is placed in the heap. Understood? Yes or no? So now coming back to our laundry example, think that there are some 10 or 15 clothes in your heap. Everything else is taken by your customers, and these 10 or 15 clothes, they don't have pointers or tags attached to them, and nobody else is claiming them. Fine. And what happened after some 1 month's time? Almost 50 or 60 cloths got piled up like that. Fine. And you are running the laundry in a single room. So is this waste of the space in your room or not? What you will do, you'll look for some time, you'll throw them out of your laundry, right? To to save the space in your laundry. Yes or no? Similarly, in your heap based memory allocation inside your RAM, what happens, every object you create will have a tag attached to it, and this tag would be held by the particular point of code which is referring to that or referencing that particular object. Fine. Like, think that there are 100 people in your class. Okay, 100 people in your class, and everyone started playing with kites. Fine. These kites are similar to your objects which are in your heap. Fine. And sometimes it might happen that two of your friends together might play with the kite. Yes or no? So once you are done with it, okay, think that the thread attached to that kite gets broken. Fine. And now this kite is of no use, right? So it will fall somewhere, right? So these kites should be removed, right? Because nobody is using them, they got damaged. So similarly, the objects which are saved in your heap, until and unless some part of your code is using that, and as we call it in technical terms as some code is referencing to that particular object, then it will have a pointer. Once the code which is referencing to it is done with the use of that particular object, the pointer will be destroyed, and this object will go orphan in your heap, and it is of no use. And think that there are you have a RAM of 2 GB, and out of which your operating system is consuming 500 MB, and remaining 1500 MB is shared among some 5 different applications, and your .NET application got 300 MB for it. And inside that 300 MB again, there are some unused or unreferenced objects placed on your heap, which each one of them on an average is accounting for 2 MB, and there are 50 objects like that. So at least 100 MB would be going useless, right? Yes or no? Understanding or not? Is it making sense or not? So this kind of unreferenced objects, they are of no use, and they'll start using your heap memory unnecessarily, so they should be destroyed, right? So this process of cleaning up of your heap memory and removing the unreferenced objects from them is called as garbage collection. Fine. And there is a component in your .NET framework which is called as garbage collector, which performs this function. And this garbage collector will have something called as optimizing engine, which will keep running itself, and which will understand when is the correct situation to start cleaning up the unreferenced objects. So periodically, based on its own algorithm, it starts running the garbage collector. Understood? Good. Fine. Let's see the time. Good. This is about your garbage collection. Fine. So now you have to look at these things. So we have almost reached the time end of the class today. So do you have any questions on what we have discussed today? We understood what is .NET framework and what is compilation, what are components of your .NET framework and how compilation happens, what are the two different phases of your compilation and which compiler is responsible for what phase and what is just-in-time compilation and what is the purpose of doing it in two different phases, what is the assembly, what is metadata, what is manifest, what is namespace and what is garbage collection. Hoping you don't have any questions, I'm dropping off for the day. If you have any questions, you can let me know.
Yeah, hi. Anil.
Yeah.
I have a doubt, but not regarding to today's class, but generally. Okay, so what happened is yesterday I was
One
trying to.
Let me stop the recording.